speaker is Geoff. He's a Svelte.js maintainer, and since Svelte 5 is coming soon, he is so excited about it, like he's got ants in his pants. Speaking of which, one time he literally had ants crawling in his pants. He was forced to strip in front of a large group. So I had a talk with him on the code of conduct at CascadiaJS. He won't be doing that today. So Geoff has a music minor, and he's got 2 cute cats, Percy and Oliver, and he enjoys gardening. He loves Svelte, but do you know what he loves more? This incredibly large zucchini from his garden. Give it up for Geoff.
All right, hello everyone. I'm Geoff. It's really great to be here. I've lived in Washington almost my whole life, and it's really great to have a conference like CascadiaJS where I don't have to fly anywhere, I can just stay local. So Svelte is a JavaScript framework that I contribute to, and today I'm going to be talking about what's changing in the next major version of Svelte and why. If I could just have a quick show of hands, like how many people actually know what Svelte is? Cool, pretty good. And then keep that hand raised if you've used Svelte in a project, be it personal or at work. All right, a little fewer. So let's level set a little bit. What is Svelte? So Svelte is a compiled, batteries included, HTML-first JavaScript framework that prioritizes vibes. So yeah, big sentence. We're going to break that down bit by bit. First, compiled. If you know anything about Svelte, it's probably that it's a compiler. So a compiler is a program that takes code written in one programming language and transforms it into another. In Svelte's case, it takes Svelte component code, which looks similar to HTML, and transforms it into tightly optimized vanilla JavaScript. Now, this was a super unique approach to front-end frameworks when Svelte first came out in 2016. These days, having a compiler in your framework is a little bit less unique. Solid.js, a lot of you might know, they use a compiler in ways similar to Svelte, but they use JSX as the template language of choice. Vue has had compiler-driven optimizations for a while now. They're also working on an experimental Vapor mode that will let them drop the virtual DOM completely in favor of using a compiler. And of course, last month, React open-sourced their experimental compiler, React Forget, so that you can stop hand-optimizing your React component rendering. But something that I think makes Svelte special is that we are compiler-first and compiler-only. Compilation is not a separate mode of the framework for us or a special flag. It's fundamental to the framework. Svelte components don't need to run in the browser as is, so we can start with what we want the authoring experience of a Svelte component to be, and use the compiler to make that possible. This results in component code with very minimal boilerplate, and also lets us make a ton of performance optimizations behind the scenes that result in small, fast web apps. So, compiled. Svelte also aims to be batteries included. Instead of only being a component framework, we also provide solutions to common web app concerns like scope styling, input bindings, intro and outro animations, and accessibility warnings, and even Spring physics. Svelte is also HTML first. We think HTML is a pretty good language for describing UI, and we want writing Svelte to feel like writing HTML. Whereas React starts with JavaScript and adds HTML to it with JSX, Svelte takes HTML and enhances it with JavaScript reactivity. We also prioritize Svelte's unique vibes. Being small and fast is great, and those are definitely priorities for us, but what we optimize for is how it feels to write Svelte and the aesthetics of it. And vibes is something we're going to come back to as we talk about the next major version of Svelte and what's changing, because I think optimizing for vibes is a key part of successfully making a breaking change. Part of making a change like this, and we'll get to what that change is in a second, is making sure that the project after the change still feels like the same project. People get attached to the vibes of whatever framework they use. And if you're changing your framework, you want the vibes to be the same, or at least similar. Because if you make a breaking change and it feels like a completely different framework, well, maybe you should have just made a new framework. But we don't think that's true with Svelte. Despite the significant changes coming in Svelte 5, we still think it feels like Svelte, and we hope our users do too. So for many of you who haven't actually used Svelte before, this is what a component currently looks like in Svelte 4. A lot of this will be changing in Svelte 5, but the shape of a Svelte component will remain, and less may change than you might think. So as I mentioned, Svelte components look like HTML. Here we have a simple counter component. At the bottom, we have the template for the component. We're rendering a button with a click handler, some text, also listing out what the value of count is as it changes. And the logic lives in the script tag at the top. You can also have a style tag containing styles scoped to the component, but we're going to mainly focus on the script section today. On the first line, we use export let to define a component prop, in this case, a text prop to set the counter button's text. You can also declare component state, just like you would a normal JavaScript variable with let. In this case, we're defining a piece of state called count that we use in the template by wrapping it in curly braces. Importantly, and what a lot of people like about Svelte, is that you can update that state variable directly without needing to use a setCount function or other framework abstraction. When we call count++ here, the DOM will automatically update with the new value of count. You can also define derived values using this $label syntax. In this case, we're creating a variable called doubled and saying that it should always be 2 times the value of count. Whenever we update count, Svelte will automatically update the value of doubled as well. $ can also define what we call a reactive block, where you can run some code after any of the state variables referenced inside the block change. In this case, whenever count is updated, this block will run and log a message if count is greater than 10. So Svelte works great today. A lot of people love Svelte. It's being used in quite a few production applications. But it's been a little bit since Svelte 3's release in 2019. It's been 5 years. And so as the current API got more and more usage, we noticed some areas of improvement. 5 years is also a long time, especially in the web dev world. 5 years ago, React had just released hooks. If you were writing React, you were probably doing so using create React app. And let's be honest, that app might still be using create React app. Vercel was known as Zeit. Vue was still on version 2 and only just proposing what would become the composition API. Solid.js wasn't well known yet. Microsoft Edge was still using its own browser engine instead of being Chromium in a trench coat. And if you were unlucky, you still had to support Internet Explorer 11. Think of how much front-end frameworks and the front end in general has changed since then. So with Svelte 5, we're taking advantage of all the learnings and innovation that's happened in the space through other frameworks in the browser and using them to make Svelte even better than it already is. So what does that actually mean? Summarized, Svelte 5's main goal is universal runtime reactivity. With this change, we hope to make Svelte more scalable and able to tackle projects of any size, and also make Svelte's mental model more consistent and easier to learn. Let's start with universal reactivity. Today, Svelte has 2 reactivity modes. There's the easy-to-use reactivity model inside Svelte components that I just showed you, but that reactivity model doesn't work if we try to move it to a separate file. Let's take another look at the example I just showed. Let's say you wanted to wrap this counter reactivity code into a utility that could be used anywhere. You can't just copy-paste the code into a JavaScript file or even move it into a function inside the component. Svelte's reactivity only works at the top level of Svelte components. Instead, to move it, we need to rewrite it to a completely different reactivity API called stores. Now, I'm going to show an example of what that might look like, but just fair warning, don't worry about actually understanding the code. The details aren't the point here. Just notice what I've highlighted in red. This is what you had to change in order to extract the code from the component. And that's a lot to change just so that we could share this reactivity between multiple places. And because that makes refactoring difficult, Svelte components often grow larger than they need to be. But what if you could just copy-paste that reactivity code into a different file and it would work? What if we could use Svelte's component reactivity model everywhere? Well, that is what universal reactivity in Svelte 5 is. But before showing what that actually looks like, let's discuss the other big change, runtime reactivity. Svelte 5 moves from compiler-based reactivity to runtime reactivity. Svelte 4's reactivity uses compile time static analysis. The compiler analyzes your code to determine which variables you're updating where, and then adds code to invalidate data at the right time. This works well most of the time, but there are some extremely tricky edge cases that are hard to solve with a compiler-based model. It makes other kinds of refactoring tricky as well. For instance, let's look at this reactive statement from earlier. Let's say that doubling a number wasn't as simple as doing count times 2, but it was some sort of verbose operation that you wanted to move into a separate function. In Svelte 4, if you do this, you'll actually break Svelte's reactivity, and doubled will no longer respond to changes in count. Doubled's dependency on count is now invisible to the compiler. Instead, and a lot of Svelte devs learn this when they're first starting off, in Svelte 4, you need to pass count as an argument so that the compiler understands that this function should rerun and update doubled when count changes. But that can be unintuitive, and it's easy to miss as the number of variables your reactive statement depends on increases. So in Svelte 5, we're changing this. Svelte 5, the compiler is no longer responsible for determining reactive dependencies. Instead, those are determined when the code runs in the browser. Now, this doesn't mean that Svelte is dropping its compiler. That's far from it. It's just not using it for reactive dependency tracking anymore. And we'll talk a little bit more about the implications of this later. So this is what Svelte 5 aims to deliver: universal runtime reactivity. Now, enough theoretics. Let's see what that looks like in practice. It's time to talk runes. So you might have heard the phrase runes before. This is the new way to express reactivity in Svelte 5. That same Svelte 4 component that we just looked at would look like this in the new reactivity system. Let's break this down. So in Svelte 5, those function-like symbols starting with a $sign are called runes. But they're not actually functions. You don't import them to use them. Instead, think of them more as instructions to Svelte's compiler. These runes replace Svelte's existing reactivity syntax. So instead of export let in Svelte 4, props are now destructured from a props rune. State variables are now declared with a state rune. Under the hood, the state rune will use something called a signal, so Svelte can perform targeted updates when this value changes. However, as far as the component author is concerned, count is just a regular number, and you can access and update it just like you would any number in JavaScript. It's not a special reactive object or a function that needs to be called. It's just a number. This is important for vibes reasons, and we'll talk a little bit more about this later. Instead of that $sign label syntax, derived values now use the derived rune, and our reactive block turns into an effect rune, which will rerun whenever any of the reactive variables inside it change. So on the surface, this may look like mostly a syntactical change, but let's talk a little bit about how it solves some of the issues from earlier. First, unlike the $sign label, derived and effect use runtime reactivity. So we can now safely refactor into functions without breaking anything. If you're using Svelte today, you don't need to learn that gotcha I mentioned about passing in reactive dependencies as arguments. With runes, we also now have universal reactivity, which means it's much easier to refactor this reactive counter into a separate file if we wanted to share it between components. Earlier, we showed how to do this in Svelte 4, and it involved rewriting to a completely different, more verbose reactivity API called stores. But in Svelte 5, not only is the reactive logic more concise than the store version, it can also be copied into a function verbatim. If you look at this function, this part highlighted in green is exactly the same as what was in the component. There's no need to convert this code into a different API. The only change is that the function now needs to return data for the component to use. And actually, let's take a closer look at what we're actually returning here, because that may look unfamiliar to some of you. Those function-like values for count and doubled are called getters. In case you haven't seen this before, it's nothing Svelte specific, it's just JavaScript. A getter is a special object function that maps to a property. When we access the count property on the returned object, it runs this count function to get that property's value. And this is important because we want to get a live reference to the count state. Remember that when you interact with count, it's just a number. And if we just returned a number here, then there would be no way to update that number after we returned it. Instead, we always want to get the live value that the increment function is updating. And that's what the getters give us. They let us return the same underlying value that the increment function is operating on and let us keep those in sync. So when wrapping up reactive state like this, you can use objects like I showed, or you can also use classes. This is also a valid way to write that same counter with count and doubled as reactive class properties. Either way, these can be used similarly. You can import them into the component, call them, and then use the values in your script tag. A lot of syntax here. I'll definitely give a link to the docs and my slides after the fact, so don't worry about capturing all this right now. So I talked earlier about how when planning this change, we wanted to make sure to preserve Svelte's vibes. So now the question is, did we succeed? Well, I think only the community can really decide that. For the most part, feedback has been positive, and people are excited about Svelte 5. But if anything looks less Svelte-like to you, it's probably that you now have to type state out instead of it being inferred. Why do we have to do that? Well, technically, we could have switched to runtime reactivity without changing the syntax. But we also wanted to unlock universal reactivity. And if we want to be able to declare state outside components, we need a way to declare it explicitly. We were able to get away with implicit state in Svelte 3 and 4 because it only applied to variables at the top level of a component. So in this Svelte 4 example, name and numbers, they are reactive state variables because they're at the top level. But sum and value are nested inside a function, so they're not reactive. But in Svelte 5, state can be anywhere. It can be at the top level of a component. It can be inside other functions, inside other files, or even inside other functions inside other files. And if we assumed every let was a state declaration, like in Svelte 4, it would get very confusing to figure out if a variable was truly reactive or not. It would also have a performance impact. Making a value reactive isn't expensive, but it would add up if we applied it to every single variable in Svelte files. It also brings a readability benefit. Code is read more often than it's written, and now you have a clear visual signifier as to what is state and what isn't. And if you're concerned about saving your fingers, well, isn't that what editor autocomplete is for? Now, if the word state makes people nervous, there's one other word that might frighten people. Effect. And I don't think effect needs to be a scary word. Maybe this is better? Svelte had effects before now in the form of reactive blocks. We just didn't call them that. Side effects are a natural concept in reactive UIs. They're often overused. Our docs encourage using derived state instead where possible, but they are necessary. And there is one important thing to note about Svelte's effect. Unlike useEffect in React, there's no dependency array. If you're familiar with Vue's watch effect or Solid's create effect, it works similarly. The effect determines when to rerun based on what reactive values you access inside it. So in this example, by accessing the values of size and color inside the effect, Svelte will automatically rerun the effect when those values change. And in case you do just want to read a value without subscribing to updates, we do provide an untrack function that lets you do that. Beyond the potentially visceral reaction to seeing words like state and effect in Svelte, the rest of what makes Svelte special is still intact. For instance, you interact with the raw state values instead of going through a setState function or object with a value property. And to understand why that's possible, we need to talk a little bit about signals. So, Svelte is finally on the signals train. Today, it feels like every framework is either using signals or about to adopt signals, well, aside from React. But what does signals actually mean? Well, a deep dive on this is definitely outside the scope of this talk, and really our goal is that you should be able to use and learn Svelte 5 without ever learning what a signal actually is. But for the curious, a signal is an object that holds a value, and that can also track when the value is read. So this means that when you update a signal's value, the signal knows all the other places that that value is used, and it can trigger updates in those places automatically. This lets you make very targeted, precise updates to your UI without a lot of wasted work. And in Svelte, we can even get more granular, tracking that, oh, you only access this object's property in this place, so we don't need to change if you update a different object's property. We can target it, for instance, just the name property on an object. But while signals are great for performance, interacting with them doesn't feel very Svelte-like. Part of what makes Svelte Svelte is this. It's the fact that you can take a reactive variable, and if you want to make changes to it, you don't have to use a set function or set a value property. You can just update the value like it's a normal JavaScript variable. But then how do we get signals to work? Remember, signals need to be able to track when a value is read and written to, and there's no way to do that with just a primitive number value in JavaScript. And this is why other frameworks have those set functions and value properties that we're trying to avoid. In Vue, when you declare a state variable with a number in it, you actually get an object back, not the number. Behind the scenes, Vue uses a proxy object that intercepts reads and writes to the value property and wires up the signal properly. And this is why in Solid, you get back two functions, one that you call to read and write the value, and that also gives Solid a way to put in the signal functionality that it needs. And there's nothing wrong with doing things this way. This is just a limitation of how JavaScript works, but it didn't feel right for Svelte. But To quote Rich Harris, when he discovered the core of Svelte 3, we don't need to be limited by what is possible at runtime in vanilla JavaScript, because we're a compiler. In Svelte, we start with what we want the authoring experience to be and use the compiler to make that possible at runtime. So in your Svelte component, you can write this, and Svelte will compile it to use signal methods under the hood. So we get the best of both worlds, an efficient, readable authoring experience that's easy for humans to write, that is then transformed into valid, optimized JavaScript for the browser to execute. Signals, but as an implementation detail. You can interact with state values like you're writing vanilla JavaScript and let Svelte's compiler handle the rest. And with Svelte 5's universal reactivity, that's true inside Svelte components as well as regular JavaScript files. All right, let's talk a little bit about performance. Svelte 4 was already fast, but Svelte 5 has made some even more significant gains in performance. A lot of that is thanks to Dominic Ganaway, creator of Inferno.js and former React team member, who joined the Svelte team last year and has been instrumental in eking out as much performance as possible. If you look at the JS framework benchmark, which tracks how long it takes various frameworks to perform different DOM updates, Svelte 5 is doing very well, way better than Svelte 4 did, and neck with Solid. And not only is Svelte 5 fast, but it also uses less memory and hydrates more quickly. There are lots of reasons why Svelte is faster now, many outside the scope of my expertise. But just to mention a couple, first, the compiler has been rewritten from the ground up with performance optimization in mind. And this involves things like making sure that the compiled JavaScript code Svelte outputs is super easy for browser engines to optimize. A lot of these may be micro-improvements, but micro-improvements definitely add up. And also, the reactivity being signal-based now, like I talked about, means that updates can be even more targeted and efficient than Svelte 4's compiler-based reactivity. Svelte is not the absolute fastest framework out there, but it is definitely almost blazingly fast. If you want to build a performant web app, Svelte is not going to require a lot of extra work from you. All right, let's talk a little bit more about bundle size. We made a couple trade-offs there. In Svelte 4, a Hello World app was only a few kilobytes, since Svelte had almost no runtime. However, because the reactivity was compiled into each component, as you added more components, the bundle size would increase at a steeper rate than frameworks with larger runtimes. With code splitting, most apps would not hit this inflection point. It would only show up in super large apps, but it was still something we wanted to address. But now, with Svelte 5, reactivity is now in the runtime, which means a slightly larger runtime, but smaller components. So a Hello World app will be slightly larger, but as you build bigger apps, you'll start to see the savings. Let's look at an example. An implementation of To-Do MVC, the famous To-Do app project used to demo different frameworks, is 7.2 kilobytes in Svelte 5 and 4.9 in Svelte 4. So Svelte 4 is obviously smaller. But let's say you have an app that's just 3 times the size of To-Do MVC. At that point, the Svelte 5 app is actually smaller than Svelte 4, 9.8 as opposed to 10.1, because the larger runtime means that not as much needs to be compiled into the component. And these savings will only increase the larger your app is. All right. I've tried to talk about as much of Svelte 5 as I can today, but there's still more stuff, and I only have 25 minutes, so I'm going to fall back to a listicle. You won't believe these other 9 features coming in Svelte 5. Snippets, event attributes derived by TypeScript and markup, reactive sets, bindable, deeply reactive objects, fine-grained reactivity, and the inspect rune. These are all things I don't have time to talk about right now, but if you check out the Svelte 5 docs right there, or come talk to me after, I'd be happy to share more about these with you. But something I find just as exciting as all the stuff we're adding is the stuff we're able to remove. These are all APIs that existed in Svelte 4 that no longer need to exist in Svelte 5, either because they've been replaced by something simpler, or the problem they solved is no longer a problem in the new design. This is the benefit of rethinking some of these APIs. Any design is going to accumulate awkward bits over time as you discover use cases that weren't considered originally, or rethink your priorities, or accept this PR that seemed like a good idea at the time. Designing from first principles means that you can create something that feels cohesive instead of tacked on. One last piece I want to touch on before closing is the migration story. This is an image I found when I searched for Ship of Theseus. I talked about a lot of changes today for how you write Svelte components. Importantly, while Svelte 5 is introducing new reactivity syntax with runes, you don't have to convert everything to use runes to start using Svelte 5. Instead, you can use your Svelte 4 components in Svelte 5 today, and they should work the same. Runes take effect on a per component level, so you can have some components written using the old reactivity, some using the new, and they should work together. Being able to incrementally migrate to the new reactivity system is super important to us, since if we require everyone using Svelte today to do a massive Big Bang rewrite to start using Svelte 5, it would be very difficult for a lot of projects to adopt it. In addition to supporting Svelte 4 style components in Svelte 5, we'll also be supplying automated migration tooling to convert your components to runes. Because even though the old reactivity model is supported in Svelte 5, it will eventually be removed in Svelte 6 or Svelte 7 in favor of runes. While it's great for adoption to support both syntaxes simultaneously, it's not great for learning and understanding. If we decided to support both forever, we would essentially split the ecosystem, where some projects would use the old component syntax, some would use the new, and if you were learning Svelte today, you would have to decide which one you wanted to learn and use. In our mind, the benefits of runes are clear, and you should be using them eventually, but you don't need to adopt them all at once, and you don't need to do it all by hand. So that is a very brief overview of Svelte 5, the changes, the problems they solve, and the exciting improvements coming to Svelte. We talked a lot about how Svelte 5 compares to its predecessor, but its simpler mental model also means that this is a great place to start trying Svelte. If you're interested in learning more or giving it a go yourself, there are a few places you can go. For now, Svelte 5 is still in preview, though theoretically we're very close to actually getting a release out there. So if you go to svelte.dev, those docs are still for Svelte 4. If you want the docs for Svelte 5, as well as an interactive playground, you can go to svelte-5-preview.vercel.app and read the docs there. Once Svelte 5 is released, it will come with an interactive tutorial that will be the best way to learn Svelte 5. If you prefer to work locally, if you run npm create svelte in your terminal, that will start a new Svelte app and give you the option to install the Svelte 5 preview if you want to try out the new stuff. If you want to find me, head over to my website at geoffrich.net, where I have my blog, links to my various socials, and you can also find my slides and a full transcript of my talk there as well. All right, thank you so much for having me. Enjoy this picture of my cats, and enjoy the rest of the conference.